It's Saturday, 2 a.m. Your phone buzzes. The customer-facing portal is offline. RDP fails. The Azure portal says the VM is running, but nothing works. No boot diagnostics, no alerts, no clue. You'll spend the next 6 hours rebuilding the entire thing. This video makes sure you never live that night again. By the end of this video, you'll walk away with 3 concrete skills that turn midnight disasters into controlled recoveries. By the end of this video, you'll walk away with 3 concrete skills. First, setting up boot diagnostics with proactive availability alerts so you catch VM boot failures before users notice. Second, onboarding VM Insights and creating custom performance alerts on counters like disk latency, the silent killer. Third, enabling NSG flow logs and querying denied traffic to catch misconfigured network rules. These 3 skills turn you from a reactive firefighter into a fortress builder. Picture a retail site on Black Friday. At 2 a.m., their main VM's boot volume silently corrupts. By 6 a.m., the site goes down and they lose $50,000 an hour. They had no boot diagnostics, no availability alert, and if a misconfigured network security group, NSG, the cloud firewall that controls traffic to your VM, was blocking access, they wouldn't know either. With boot diagnostics, availability alerts, and NSG flow logs enabled, they'd catch the disk error screenshot hours before the outage, and a simple alert would page the on-call. Proactive monitoring isn't optional. It's the difference between a 5-minute fix and a 5-figure loss. Let's step back and look at the complete monitoring picture. Every virtual machine generates several different types of information, and each serves a different purpose. Boot diagnostics captures screenshots and serial logs before the operating system is fully running. Azure Monitor collects platform metrics directly from Azure, such as CPU utilization, network throughput, and VM availability. Inside the guest operating system, the Azure Monitor agent gathers performance counters and sends them to a log analytics workspace through data collection rules, which define exactly what information should be collected. Network security group flow logs record allowed and denied network traffic, while the serial console provides direct access when RDP or SSH isn't available. Together, these services create a layered monitoring strategy that helps you detect, diagnose, and resolve problems before they become outages. Quick recall checkpoint. What 2 pieces of data do boot diagnostics capture during a VM boot or crash? And what type of Azure service stores this data? The answer: screenshots and serial logs stored in an Azure storage account. You're staring at a boot diagnostics screenshot. The Windows VM threw a stop error. Inaccessible boot device. That single line tells you the OS can't reach its boot disk. No guesswork. Immediately check disk connectivity or corruption. That one screenshot saves you hours of random troubleshooting. So you pull up the serial console log. At the top, a kernel panic message. Kernel panic, not syncing. VFS, unable to mount root FS on unknown block. That's the OS telling you it can't find the root file system. Usually it's a missing storage driver or a broken grub configuration, and we'll show how to fix that with a disk swap coming up. Don't wait until a crash triggers you. Set up a proactive alert on the VM availability metric, not the agent heartbeat, because that can lie. If availability drops below 1 for 5 minutes, Azure pages your team instantly. You'll know the VM has truly gone unavailable before any user notices. Time to lock in what you've learned. What might a kernel panic in the serial console indicate, and which metric should you alert on to be absolutely sure the VM is unavailable? The answer: a kernel panic message in the serial log is a strong sign the OS has halted. And you must alert on the VM availability metric, not the heartbeat, because the heartbeat can lie when the agent or network is unhealthy, even though the VM is running fine. It's the middle of the night. You apply a kernel update, reboot, and nothing. The portal says running, but SSH is dead, RDP is dead. The VM is really sitting at a grub rescue prompt, the Linux bootloader that loads the operating system, waiting for input. Here's the mistake that burns teams the most, assuming the portal status means a healthy VM. Without serial console, your only option is to detach the OS disk, attach it to a rescue VM, fix grub, reattach, a solid hour of stress. With serial console, you open the portal blade, log in, run a couple of commands, and reboot. 5 minutes later, you're back online. That's the power of having a direct console connection. Go to your VM in the portal, scroll to the Help section, and click Serial Console. It drops you into a terminal. If you have local credentials, just log in. On Windows VMs, the Serial Console provides access to the Special Administrative Console, SAC, a basic command line environment for initial troubleshooting. On Linux, you can use sysrq keys, magic key combinations recognized by the kernel for low-level commands, to force a safe reboot, for example, pressing Alt-sysrq plus B. Keep in mind, if the VM uses Entra ID authentication and password-based sign-in isn't enabled, you may not be able to log in via Serial Console, but you can still view boot diagnostics and run repair commands like azvm repair from outside the VM, so you're never completely blind. And here's the catch that burns teams the most. If you haven't enabled boot diagnostics before a crash, this console is useless, so lock that in now. When you can't fix the VM from the console, the old manual disk swap was a nightmare. Detach, attach, mount, fix, reverse. Azure now gives you a repair create command that automates the entire rescue VM process. 2 commands, and you're done. Serial Console and Disk Recall Checkpoint. What 2 commands replace the manual disk swap recovery? The answer: azvm repair create and azvm repair restore. One of the biggest mistakes new Azure administrators make is waiting for users to report performance issues. VM Insights changes that by continuously collecting operating system performance data and presenting it in a way that's easy to understand. Behind the scenes, the Azure Monitor agent gathers metrics like CPU utilization, available memory, disk latency, and network throughput, then sends them to Azure Monitor through data collection rules. Instead of staring at individual counters, you can immediately recognize trends. Is CPU steadily climbing every afternoon? Is disk latency increasing every week? Is memory slowly disappearing because of a leak? These patterns often appear hours, or even days, before applications begin to fail. Enterprise monitoring isn't about reacting to outages. It's about recognizing warning signs early enough to prevent them. Getting VM Insights running is straightforward. Go to your VM, under Monitoring, click Insights, then hit Enable. The wizard lets you pick an existing log analytics workspace or create a new one. Click Configure, and the Azure Monitor agent installs automatically on the VM. After a few minutes, the Performance tab will start showing charts like CPU, memory, and disk as data flows in. Don't collect everything. Focus on the 5 counters that will alert you before things go south. total CPU time, available memory, if it drops below 100 megabytes, game over soon, disk transfers per second, average disk seconds per transfer, that's your latency canary, and network bytes per second. These 5 paint a picture of VM health and let you catch CPU hogs, memory leaks, disk thrashing, or network saturation long before users notice. But keep in mind, every workload has its own normal. Treat these as guides, not fixed rules. Here's a general guideline. Many admins find disk latency under 10 meters acceptable. Between 10 and 30 meters is a warning zone, and over 30 meters can seriously impact database performance. VM Insights trends this over time. When you see the average disk seconds per transfer line, climb toward that upper range. It's time to scale up disk performance before your help desk lights up. Exact thresholds will depend on your workload, but these numbers are a solid starting point. Stop. Here's where 90% of admins get this wrong. They only watch CPU and memory. The real silent killer is disk latency, a metric that leaves no obvious trace until the app times out. Lock this in now. Imagine your monitoring agent crashes because Windows becomes unstable. The heartbeat immediately disappears and your alert fires. But is the virtual machine actually down? Not necessarily. This is why experienced Azure engineers separate guest monitoring from platform monitoring. Guest metrics depend on software running inside the operating system. Platform metrics come directly from the Azure hypervisor and remain available even when the operating system is unhealthy. VM availability is one of those platform metrics, making it one of the most trustworthy indicators for production alerting. By combining platform metrics with guest performance counters, you gain a complete picture of both infrastructure health and operating system health without relying on a single source of information. Open Azure. Monitor alerts, create a new rule, and scope it to your VM. Choose a signal like average disk seconds on transfer. That's your disk latency. Set the threshold to reflect your warning level, for example, 0 or 3 seconds, 30 milliseconds. Set the evaluation to every 5 minutes and assign an action group to email your team. Now, if latency stays high, you'll know before users do. A few months ago, a team spent an entire afternoon chasing a ghost. Their microservice couldn't reach the SQL Server database. The app logs just said, "Connection refused." The DB was up, everything looked fine. After 3 hours, they found the culprit. Someone added an NSG rule that denied inbound traffic on port 1433. They'd forgotten to add a matching allow rule higher up. If they'd had NSG flow logs enabled, they'd have run a 1-minute query, seen destination port 1433, flow status denied, and fixed it immediately instead of burning 3 hours. Flow logs don't just show allowed traffic. They capture every denied attempt with the exact NSG rule name that blocked it. Next, I'll show you how to turn that on. Network problems often look like application failures, but the real cause is frequently a blocked connection. Azure Network Security Group flow logs capture every allowed and denied network flow, giving you the evidence needed to identify exactly where communication stopped. When combined with traffic analytics and log analytics, those raw flow records become searchable dashboards that highlight blocked ports, unexpected traffic patterns, and communication failures between workloads. Instead of guessing whether an NSG caused the outage, you can verify it within minutes using real network telemetry. This transforms troubleshooting from trial and error into evidence-based investigation. Once logs are in a log analytics workspace, you can use a Custo query like this one. It filters the Azure Diagnostics table for network security group flow events that are inbound and denied. Then projects the timestamp, source and destination IPs, destination port, and the NSG name that dropped the traffic. Run it, and you'll see which NSG blocked your RDP or SQL connectivity. If you need the exact rule, you'd extend the query to extract from the NSG rules JSS field. Time for a quick recall check. What's a sample Custo query that lists inbound denied flows, and what extra field reveals the specific rule? The query filters Azure Diagnostics for denied inbound NSG flow events, projects the key fields including the NSG name. To get the rule name, you'd extract from NSG rules. When RDP is dead, don't panic. Follow this playbook. First, check the VM's resource health to confirm the platform isn't the issue. Second, verify the network security group still allows inbound RDP on port 3389 using effective security rules. Third, review boot diagnostics for any Windows stop errors. An OS crash blocks RDP, even if the VM appears running. Fourth, use reset configuration only to reset RDP settings without affecting credentials. This resolves many RDP connectivity problems. Fifth, if you still can't connect, access the serial console and check the system event logs. These 5 steps resolve a large share of RDP tickets. If RDP is stuck and you don't want to change any passwords, go to your VM, click Help, then Reset Password. Don't panic. Select Reset Configuration Only. This option restarts the remote desktop service and attempts to reset the RDP configuration. It's the safest first move for a hung session. Click Update, wait a few minutes, and try connecting again. If RDP still won't connect after a config reset, dig into the Windows event logs. From the serial console, run this wevtootle command to look for Remote Connection Manager events 1058 or 1057. Those indicate the VM failed to create a self-signed RDP certificate. Next, check Channel Event ID 36870. That means a TLS credential access error. In both cases, you'll likely find the machine keys folder permissions are broken. That's the folder where Windows stores private keys for services like RDP, or the RDP certificate thumbprint in the registry is wrong. Fix those, and RDP comes back. When SSH refuses your connection, start from the outside and work in. First, confirm the NSG still allows inbound TCP/22. If that's fine, use the serial console to check whether SSHD is actually running with systemctl status SSHD. Then look at the boot diagnostics to rule out kernel panics. A crash will drop SSH. Next, tail auth.log for authentication failures. Maybe your key isn't accepted. And here's a critical one. Check disk space. A full root file system can prevent SSH from accepting new connections or cause it to behave unpredictably. If logs have eaten your disk, clean them up and restart SSH. Monitoring tells you that something is wrong. Performance diagnostics helps explain why. After you've identified high disk latency, excessive CPU usage, or memory pressure through Azure Monitor, Performance Diagnostics performs a deeper investigation into the virtual machine itself. A quick analysis can identify common issues within minutes, while a full analysis gathers additional diagnostic information over a longer period for more complex performance problems. Rather than replacing Azure Monitor, Performance Diagnostics complements it by validating your observations and providing recommendations that help you move from symptom to root cause much faster. Time to lock in what you've just heard about performance troubleshooting. Hit the question coming up now. Now turn that insight into a proactive monitor. This query, averaging disk latency every 5 minutes, can serve as the foundation for a log alert rule. You'd configure it in Azure Monitor to fire when the average climbs above 30 milliseconds, giving you early warning before disk latency drags down your application. Mixed recall. Disk smarts. Checkpoint. So that's the whole playbook. Boot diagnostics with availability alerts, VM Insights with custom performance queries, and NSG flow logs backed by the serial console. 3 pillars that turn frantic firefighting into a calm, repeatable process. You now know not just the buttons to click, but exactly what each diagnostic layer tells you. No guesswork required. Let's bring everything together. Start with boot diagnostics, so every startup problem leaves behind evidence. Add platform alerts based on VM availability to detect infrastructure failures immediately. Enable VM Insights to monitor CPU, memory, disk, and network performance over time. Collect network telemetry through Network Security Group flow logs and traffic analytics, so connectivity issues never become mysteries. Finally, create meaningful alert rules that notify the right people before users notice service degradation. This layered approach transforms Azure monitoring from a collection of individual tools into a complete operational strategy. In the next lesson, we'll build on that foundation with Azure Backup and Site Recovery, completing another essential piece of enterprise resilience. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.